let's talk about a pretty cool pigment and color mutation called axanthism. This is a frog with axanthism. Now, axanthism is a pretty cool one because it involves the lack of a pigment like many other ones like erythrism and albinism. This one in specific involves the xanthophores, which are specific yellow producing pigment cells. Axanthism is basically the opposite of xanthism, which is the overproduction of the yellow pigment, causing animals to appear more orange or yellow than they should. Axanthism is the opposite of that, where no yellow is produced, so animals appear more blue than they should. This is almost always only seen in frogs and a couple, maybe select few bird species. It's most obvious in animals that are supposed to be green or brownish. Like this guy is supposed to have a green head, but it doesn't. It has a blue head instead due to the lack of yellow pigment. Usually in green animals, the yellow and the blue producing pigment cells work together to create the green color. There's no actual green pigmentation. There's the yellow and there's the blue pigment cells. I mean, not technically blue pigment cells because actual blue pigment is very rare. They're blue reflecting cells. In the case of almost all blue animals, the blue pigment is not produced naturally by the cells, it's just blue wavelights reflecting off in a specific order. In most green animals, the blue light is reflected off of the blue light cells and goes through the xanthophores, or the yellow cells, causing them to kind of not mix, but essentially mix visually together to create the green. However, without essentially a yellow light filter, there is nothing causing the blue to stop appearing blue, and instead of appearing green like they should, they're just blue instead. This is almost always only seen in frogs, and if you Google axanthism, pretty much all of the images that come up will be of frogs, because there's not a whole lot of green animals out there that require the blue light cells to appear green. And while it's not super common in frogs either, it's not super rare, and like many color-based mutations, it's not inherently harmful. In some cases, like albinism, it can come with quite a few more detrimental physical traits, like affecting the eyes and all that, but axanthism, xanthism, and something like erythrism with an overabundance of red pigment, the majority of the time they're not inherently harmful. However, they do come with a bunch of extra struggles from things like being very, very visible to predators and other threats. Because as you see, especially apparent on this background here, a bright blue frog is much more noticeable than, say, a greenish, brownish, muddy looking frog. So it makes it quite a bit harder for animals to hide and avoid predators. Here's another example. These guys are lovebirds, and normally this blue part would be green and this white part would be yellow. However, since there's a total lack of yellow pigment, there is nothing at all to pigment the top part, so instead of being yellow, it's just white because there is no coloration at all. Vaguely similar to the effects of albinism, but not the same mechanism. And then in the blue part, there's only one working color instead of two, so instead of combining for the effect, it is just the blue showing through. And like I said before, while it does have some difficulties, it's not inherently harmful as far as I'm aware. And especially in captivity with things like these lovebirds, it can make for a very interesting feature.